In this video I'm going to demonstrate how to use Tinkercad to create circuits. And so when you open Tinkercad you should be, say here on the 3D designs, you have to click circuits here and then create new circuit. And you'll get a palette in which to work. So first thing we want to do is pull out a breadboard here. And for the power source, what we're going to do is we're going to get the 6 volts that we've been using, so you have to go up here to all and look for the AA battery, and it's down here in the power area. So pull that battery over here like so, and then you can actually have 4 of them and it'll make it into a battery pack just like we've been using. So let's go ahead and connect that up to our circuit. And so the one on the left is the negative, and I'm going to bring that down here. If you'll recall, in a breadboard, these are all connected together. So if I click here, and then I can click again here, and I can attempt to make this look somewhat organized, and come down, say, to here, and then tie in right there. And now we've got this entire rail here at the negative, or the ground of this power system. And for the and actually I do want to make that black. Okay, so for this one we want to place this one on the red rail on the other side. So if I click it right about there and come over like so and change that wire to red, then I've got power 6 volts here and ground here, so I'm ready to go. So the first circuit you're going to make is a simple series circuit. So let's bring over a resistor, and if we put a resistor like this on the breadboard, then we're just shorting those two terminals together, terminal 1 and terminal 2, because you'll recall wherever you see the green pop, those are all shorted together underneath the plastic part of the breadboard. So in order to fix that, you may recall we can use this rotation tool to put it into 2 separate rows, 18 and 22. So we're okay there. And now we want to click on here and change the resistance to 330 ohms. Not kilo ohms, but ohms. We're going to find out that that is orange, orange, brown in the color code. We'll do that sometime in the future. So now I have this, and I want to put an LED in, and I think we agreed that the anode needs to be in the more positive side of the circuit, and the cathode the more negative. So we're okay right there. And now what I need to do is just hook in to the interior of the board to connect my circuit elements with the positive and negative rails I have here. So let me do that. So I'm going to go from positive here to, say, here. And on the negative side, I can go from here to anywhere, really. Say here. And I'm going to leave those green. And let's trace out the circuit. So we come through here at 6 volts, and the current will flow through here. And you can see I made a mistake here. So I'm going to double click. I missed it. I'm on 21 where I should be on 22. I guess I could drag it over like that. And now let's see what happens here. Electrons are pushed through here, come through here, and then come through the resistor, and then go through the anode, the cathode of the LED, over to here, and then back home to ground. Let's see if that works by starting the simulation. And it does. Great. Okay. Okay, so that should be relatively straightforward. Let's put on the measuring tools, the voltmeters and ammeters. So we're going to have two voltmeters because we want to check the voltage across each circuit element. So we'll put one here and we'll put one up here. And the one on the bottom is, we'll use that to measure the voltage drop across the resistor. We can predict what these are through Ohm's law, but let's go ahead and just go ahead and do it in Tinkercad here. So this is the negative side of the voltmeter, so I'm going to tie in right there on the negative side, the lower voltage side of the resistor. And again, I'm going to try to make this somewhat organized. So maybe come out to here and then up to there. And even though these wires crossed, they do not electrically interact with each other. So that'll be black again. And then for the positive side of the voltmeter, we'll click there and then here, come out to about here, and then up to right there. And we'll make that one red again. And that should tell us the voltage drop across that resistor when we start the simulation. And it says we have a drop of about 4 volts. And that kind of makes sense because our battery gives us 6 volts. We know that we have roughly 2 volts. I think Tinkercad always puts about 2 volts across an LED. And it doesn't say 4.0, I think, because Tinkercad purposefully introduces some slight noise so that everything doesn't come out perfect, as it won't in the real world as well. Okay, that's looking good. Let's go ahead and measure the voltage across the LED, and to do that we're going to have to find some places to stick it into the breadboard. I'm going to actually move this one down here, or attempt to, this guy right here, so I can have a little room. So that should still work. So if I start the simulation, yeah, I haven't done anything different because I've just moved that connection to the voltmeter along one of these rows here. So I'm okay, but that gives me a place to tie in right there with the positive side of the voltmeter for the LED. That would be right there. And I'm going to make that red as well. And once again, I think I'm going to take this wire and just drop it back one so that I have some place to put in the negative part of the voltmeter, which has to be on the other terminal of the LED. Let's make that one black as well. And I don't think I've changed anything by moving a few things around, but I have, I believe, yeah. So we see about 2.1 across the LED, which we expect, and what's left by Kirchhoff's voltage law is about 4 volts because our power supply is 6 volts. Okay, so we're in good shape there. Now what I want to do is I want to take a meter and I want to turn it into an ammeter. And to do that, you'll recall I need to break the circuit open and make the ammeter part of the circuit, make it a big wire. So to do that, what I'm going to do is I'm going to take this one here and I'm going to delete it, Control X. And instead, I'm going to come here, which is sort of the last part of the circuit before it goes to ground. I'm going to come through here and over to here and here and then up to here. So the current has to come through the resistor, through the LED, completely through the ammeter, and then it'll come home to ground. And By that I mean the following. Let me stick with the convention of having the measuring devices also have red and black. So from here to here to here, and then I need to come back home to there, and that will be black. And that should be the ammeter. So let's trace the current. So the current comes through here, along here, through this wire, through the resistor, first through the anode, through the LED, through the cathode, over, and then directly through the ammeter, back home to ground, and then back in. Recall that a voltmeter has essentially infinite resistance, so it's when I put these in here, no current's going to flow up the leads of the voltmeter, and the ammeter has essentially zero resistance, so it will act just like a wire for all practical purposes. So let's start the simulation, and we need to change this to ammeter. So I don't know if this is a bug in Tinkercad, but I couldn't get this to change before I started the simulation. So we have the familiar voltages we had before, and we have the correct current, 12 milliamps or so, if you do the calculation. So this is a completed circuit for a series circuit, 330 ohm resistor and an LED. And thanks for watching.